So today we will learn about some trigonometrical identities and compound angles formulas. So first identity, but before talking about identities, let's recall some reciprocal trigonometric functions. So you know that there are functions sine x, cos x, and tan x. But there are also reciprocal functions, which called secant x, which is 1 over cosine x. There is a cosecant x. Sometimes write just C as C, as a shortened version x, which is equal 1 on sine x, and cotangent x, which is equal 1 over tan x. So they are reciprocal, just 1 over. Later on we'll look into the graphs of those functions, but that later on. Today we will work with some identities. First identity is that you should know by now is the Pythagorean identity that sine squared x plus cos squared x equals 1. Familiar with it?
Yeah.
So I don't need to explain where it came from. Just from the unit circle and it's Pythagoras. Now, that's first identity that we will be using. Now, let's consider second identity. Let's do 1 plus tan squared x. What it will be equal? Tan is sine over cos. So if we substitute and bring to the common denominator, what it will be? We'll do bring common denominator. Tan squared is a sine squared over cos squared. So we'll get sine squared x plus cos squared x
1 over cos squared.
over cos squared x, which is 1 on cos squared x, which is, if you look here, is secant squared x. Make sense?
Yeah.
Now, what will be 1 plus cotangent squared equal? Using exactly the same approach, using bring to common denominator and using the
1 plus cos and sine. Is it cos
cotangent will, if tan is sine over cos, cotangent is reciprocal will be cos over sine, and if you bring it to, that will be 1 over sine squared or cosecant squared x. And using those identities, we can simplify a lot of different trigonometrical expressions. As an example, let's have a look into the question 8 on the page 25 from the booklet, when we need to simplify the next expression. Tan squared x over 1 plus tan squared x. So not simplify, we need to prove that this equals sine squared x. Sine squared x. So what we will do? We already know 1 plus tan squared equal secant squared x. So we have tan squared over secant squared x equal secant squared is 1 cos squared, And tan squared is a sine over cos squared. So we will get sine squared over cos squared x times cos squared x, because divided by cos squared is times by cos squared. Cancels out, equals sine squared x. What is required? Make sense? Now, as we limit it in time, I will talk about the compound angles. So, make sense what I did? Yeah. And they pretty much all this type of equation, they are pretty similar. We just need to use Pythagorean identity to simplify it. Now, compound angles. So, compound angles when we have, let's say, sine x plus y. Two angles, sine x plus y. It's equal sine x cos y plus cos x sine y. I will not be deriving those formulas, you are not required to do so, but it all can be derived just from the unit circle. Just drawing the angles and rotating. If someone will be interested, can later on show how to derive those formulas. Now, sine x, and you don't have to memorize them, they all in formula sheet. Don't have to memorize, but we will learn how to operate with them. Sine x minus y, we will have equal sine, we will have sine x cos y minus sine minus cos x sine y. Cos x plus y will be equal cos x times cos y. Cosine x plus y is cosine x cosine y minus sine x sine y. Sine, sine. Cos x minus y, cos x minus y will be, x minus y will be equal cos x cos y plus sine x sine y. And 10 x plus y equal 10x plus 10y over 1 minus 10x times 10y. And 10x minus y.
Oh shit. That's the formula for the angles, right?
X and y are angles.
I know, I'm saying the tan x plus tan y over 1 minus is the formula for calculating the angle between.
So to find what's equal 10x plus y. So we have 10x minus y will be 10x minus 10y over 1 plus 10x 10y. Now, can you make a guess? Why, when we change in plus to minus, why those things changes? How, according to what they are changing? Symmetry properties of the circular functions. If we have always refer to the unit circle. If we have this is x and this is minus x. Cos x, cos negative x equal cos x, because cos is the x coordinate. And sine minus x equal minus sine x, because sine is a y coordinate. Pretty much that is the symmetry properties in the base way changing of the signs, plus and minus. Now, looking on these formulas, can you tell me what will be sine double angle, sine 2x equal? Looking on the top line.
2 sine theta plus theta.
Yes, it will be equal to 2 sine x cos x. Because what does it mean 2x? That means this y equals x. We have x plus x. And we will get sine x cos x plus cos x sine x, which is 2 sine x cos x. Make sense? Now what will be cos 2x equal? Take y equals x.
Cos square x minus sine square.
Yes, cos squared x minus sine squared x. And what will be 10? I intentionally making some space here. I will do something in this space. But what will be 10 to x equal? Using this formula.
2 tan of x divided by 1 minus 2 tan x.
2 10x over 1 minus, not 2. 10x times 10x, 10 squared. 1 minus 10 squared x. Make sense how we obtain those formulas? Now, here I will write Pythagorean identity under this. Cos squared x plus sine squared x. What is equal cos squared plus sine squared?
1.
1 equals 1. Let's add these two. Let's add these two formulas. Formula 1 plus formula 2. What we will get if we add them? What we will get on the left hand side? We add formulas, add equations, left hand side to left hand side, right hand side to right hand side. So what we will get when we get add them? 1 plus cos 2x. What we will get when we add these two?
2 cos squared x.
2 cos squared x. So from here, we can, no, if we say, let's say 2x equals y. 2x equals y. What will be x equals then?
1 and 2.
Then x equals y on 2. And so we can get from here formula for the half angle. So we will get that we'll get now 1 plus cos y equal to cos squared y on 2. What will be cos y on 2 equal from here? Cos y on 2 equal from here.
The square plus or minus.
Plus or minus, excellent. Plus or minus square root of 1 plus cos y over 2. How long? How much long? Okay, 5 minutes? Yeah. Again, how we can find sine y on 2? From here. How we can derive sine y
Why
on
do
2?
we need sine, like cos y, y 2, like what is it?
cos of the half angle. Okay, I will answer this question. I'll give an example. Let's find, for example, cos pi on 8. What is it? Cos pi on 8. You don't know exact value, right?
Yeah.
But you know cos of double angle. You know cos of pi on 4. Using this formula, it will be equal square root. Why don't put plus minus here, only plus? Why I don't put plus minus and only plus?
First quadrant.
Because it's in the first quadrant and cos is positive then. Square root of 1 plus cos pi on 4 over 2. Cos pi on 4 is, what is cos pi on 4?
Root 2 on 2.
Root 2 on 2. So equals square root of 1 plus root 2 on 2 over 2. Well, this can be simplified further. I just showed an example where we can use half angle formula to find the exact value of the angles which are not in the basic exact values pi on 6, on 4 and on 3. So using those and combinations of them we can find all, not any, but majority of the ends we can find exact values.
Really?
Yes. Now, sine y on 2. Can you, from these two formulas, what will be sine y on 2 equal?
No flipping clue. Why can't we use...
Now you need to subtract them.
No, why can't you use cos to it, sine to x as
So
well?
it's cos,
Because from sine to x you will not get the formula.
is it plus or minus square root? No, plus or minus the square root of
If you subtract 1 minus cos 2, cos y on 2. Because if you subtract, then cos will cancel out and we'll get 2 sine squared, which we can get this. And yeah, in a similar way we can find 10 half angle and just need to do now practice with them finding the values of the angles, of the exact values of the ends and simplifying expressions. That will be all that what I'm explaining for today. Like, subscribe and donate to help to fight terrorist countries and organizations like Russia and Hamas, support Israel and Ukraine.